Hello everyone. Today I would like to discuss a very interesting topic, which is relationship between compressive strength of concrete and water cement ratio. Uh, Basically this is a very need to know topic for a civil engineer and especially those who are involved in a construction process. Before going to the original discussion, I have listed the contributing factors that affect the compressive strength of concrete. Here I have listed total 22 factors that starts with water cement ratio and ends with mineral admixtures. Each of these factors affects compressive strength in different way. I would like to discuss the factor water cement ratio here. So basically here two type of scenario is considered here for incompletely compacted concrete and fully compacted concrete. I will only discuss the incompletely compacted concrete here. So here you can see that very simply with the increase of water cement ratio, the strength of concrete actually increases up to a certain point. And then with the increase of water cement ratio, the strength actually decreases. This can be explained from different point of view, but here I have explained from the concept of porosity and hydration. So just a small review, what is porosity and hydration of concrete. Porosity is actually simply the measure of volume of voids in a concrete. And here you can see that a table, there are different kinds of pores within the concrete. This may be capillary pore or gel pores. However, hydration, everybody knows it, like hydration is actually when Portland cement is mixed with water, its constituent compounds undergo a series of chemical reactions which are responsible for the hardening of concrete. So actually the hardening part of concrete depends on the hydration reaction, the reaction of water with the components of cement. In this diagram you can see that the different components and their degree of hydration that changes with respect to time. So definitely porosity and hydration actually affects the compressive strength of concrete. So this is the diagram where I will clearly explain the scenario. So basically when we have a very low water cement ratio, the hydration products or gel, which is actually formed by the hydration reaction, there is actually not sufficient space for the hydration products to be formed. So since hydration, there is not sufficient space for the hydration products to be formed, there is actually the hydration is not completed yet at low water cement ratio. So the strength definitely low. If we increase the water cement ratio like 0.35 to 0.45, this region, here you can see that the pores are empty and actually the hydration products or gel are actually fully occupied. The hydration reaction becomes complete within this water cement ratio. What happens if we increase the water cement ratio above this point like 0.5, 0.6 or 0.7? So here you can clearly see that we have two kinds of pore. Early I have discussed that we have gel pores and capillary pores within the cement paste, like within the concrete. So the capillary pores are now occupied with water, and what happens is the excess water will not be consumed in the hydration reaction and will remain in the capillary pores space, no matter how well the concrete has been compacted. So this doesn't help. These capillary pores, the water in the capillary pores doesn't help the concrete, and actually the strength is lower within this water cement ratio. So the ideal scenario is like within 0.35 to 0.45, the pores are empty, the porosity is minimum, and the strength is maximum. So I have explained all this scenario with these bullet points. There are 6 points to explain this feature. I have collected all this information from the concrete second edition. The writer name are given. For any related question you can ask me. Thank you.